Hi, hello everybody. This is your Srinivasa. Welcome to Srinivasa Academy. Dear students, those who are watching first time my YouTube channel Srinivasa Academy, please do subscribe immediately so that you will get notifications related to Eamcet, Eapcet instructions and shortcut methods, etc. etc. And moreover, whenever a new content is added to the channel, immediately you will get notification. Okay, dear friends, past 1 month I have tried my level best to give information about your syllabus, shortcut methods, topic wise questions, etc. etc. But due to insufficient time, these 4 to 5 days I am trying to discuss previous Eamcet questions from past years, okay, and almost all important models from various topics, not from single topic. Okay, in that way, today I have come in front of you with some more topic previous Eamcet questions. They are 2D straight lines, 3D straight lines, DCs and DRs, vectors. Okay, very important concept. Compulsory we can expect minimum 2 to 3 questions from these models. Okay, let's go to first question. In the first question, do observe that if t is a parameter, capital A is equals to a sec t comma b tan t, capital B is equals to minus a tan t comma b sec t, and O is equals to 0 comma 0, then the locus of the centroid of triangle ABC. We know very well that in locus problems, whenever parameter is given, final locus equation obtained by eliminating the parameter. Okay, here centroid of a triangle locus we need to find. Locus of centroid of a triangle. Let the centroid be x comma y. Not only this, to find the locus of any point, our first step is to consider x comma y be the locus point. Do observe that centroid x comma y will be, centroid formula is x1 plus x2 plus x3 by 3, x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3. Okay, in that way we get a into sec t minus b into tan t plus 0 by 3 comma minus a into tan t, b into tan t plus b into sec t by 3. Okay, equating x coordinates, y coordinates, 3x by a is equals to sec t minus tan t, 3y by b is equals to tan t plus sec t. In order to eliminate t from these equations, it is enough to multiply 3x by a into 3y by b is equals to sec t minus tan t into sec t plus tan t. Why? Because in secant and tan terms we have an identity which is 9xy is equals to ab into secant square minus tan square. Secant square t minus tan square, t is 1. Therefore 9xy is equals to ab can be seen in third option. This is the way to find equation of locus when parameter is involved. Next, let's move on to question number 2. The range of small a so that a square x square plus 2xy plus 4y square is equals to 0 represent two distinct lines is. So whenever second degree homogeneous equation ax square plus 2hxy plus by square is equals to 0 represents two distinct lines, condition is h square greater than ab. Condition is h square greater than ab. In that way a square x square plus 2xy plus 4y square is equals to 0 represents two distinct lines. Here h value is 1, square greater than 4 times a square. This implies a square less than 1 by 4. This implies 4a square minus 1 less than 0. This implies 2a plus 1 into 2a minus 1 less than 0. Using wavy curve method, we get minus infinity, plus infinity, somewhere here minus 1 by 2. This is plus 1 by 2. Right extreme plus, minus, plus. In order to get negative region that is there in between minus 1 by 2 and plus 1 by 2. Therefore, a belongs to open interval minus 1 by 2 comma plus 1 by 2. So that is nothing but minus 1 by 2 less than a less than 1 by 2. This is the region. A should lie in this interval. That's why third option is right answer. Okay. Question number 3. If theta is the acute angle between the lines joining the origin and the point of intersection of the curve x square plus xy plus y square plus x plus 3y plus 1 is equals to 0 and the straight line x plus y plus 2 is equals to 0, then cos theta is equals to how much? Do observe that here given question is this is a curve and this is a line. Curve and line both are intersecting in two distinct points, capital A and capital B. These are line segments joining the points of intersections and origin. Yellow colored lines represents a pair of lines passing through the origin. In order to get a pair of lines equation, we need to homogenizing the curve by the line. Homogenization of the curve by the line. The procedure is x plus y plus 2 is equals to 0 can be written as x plus y is equals to minus 2. This is x plus y by minus 2 is equals to 1 and x square plus xy plus y square plus x into 1 that is x plus y by minus 2 plus 3y into 1 that is x plus y by minus 2 plus 1 into x plus y by minus 2 whole square is equals to 0. Okay. Here single variable is enough to get second degree. Single variable is enough to get second degree. Here two variables are required. That's why square we have used. X square plus xy plus y square plus x square plus xy by minus 2 plus 3xy plus 3y square by minus 2 plus x square plus y square plus 2xy by 4 is equals to 0. LCM is 4. Okay. LCM is 4. 4x square minus 2x square. 4x square minus 2x square plus 2x square plus x square 3x square. Xy terms 4xy minus 2xy plus 2xy minus 6xy minus 4xy plus 2xy minus 2xy. Y square terms 4y square minus 6y square minus 2y square plus 4y plus y square minus 2y square plus y square is equals to 0. Okay, so this is homogeneous equation. In order to find cos theta, formula is modulus a plus b by under root a minus b whole square plus 4h square. This is modulus a plus b 3 plus minus 1 by under root a minus b whole square 3 plus 1 whole square 16. See, 2h is minus 2, 4h square will be 4. This is 3 minus 1, 2 by root 20. Root 20 can be written as 2 root 5, which is 1 by root 5. Okay, 1 by root 5 can be seen in option 2. Simple homogenizing the curve by the line is important. Next problem, problem number 4. A straight line parallel to the line y is equals to root 3x passes through q2 comma 3 and cuts the line 2x plus 4y minus 27 is equals to 0 at p. Then the length of the line segment PQ. So this is a straight line y is equals to root 3x. This is intersecting another line 2x plus 4y minus 27 is equals to 0 at the point passes through q2 comma 3, intersecting this line at the point P. Then what is the distance between P and Q? Very clear, y is equals to root 3x, straight line slope is root 3. When slope is root 3, inclination is 60 degrees. Okay, treating this as a point x1 comma y1, here to here distance is r. Now we will get P point coordinates x1 plus r cos theta comma y1 plus r sin theta. In that way, 2 plus r we don't know, cos 60 degrees, 3 plus r we don't know, sin 60 degrees. This is 2 plus r by 2, 3 plus r root 3 by 2. Okay, this is the point lies on the line. This is the point lies on the line 2x plus 4y minus 27 is equals to 0. That's why P point should satisfy the equation of the line, that is 2 into 2 plus r by 2 plus 4 into 3 plus r root 3 by 2 minus 27 is equals to 0. Okay, this is LCM is 2. 2 into 2, 4 into 2, 8 plus 2r. 2 into 3, 6 into 4, 24 plus 4r root 3 minus 54 is equals to 0. 2r plus 4r root 3, 8 plus 24, 32. 32 minus 54 is a minus 22, bringing that side. Here 2r taken out common, 1 plus 2 root 3 is equals to 22 taking to that side 32, this will be 22. After the cancellation it will be 11. Therefore r is equals to 11 by 2 root 3 plus 1. 2 root 3 plus 1. Rationalizing the denominator, 11 into 2 root 3 minus 1 by 2 root 3 plus 1 into 2 root 3 minus 1, 12 minus 1. This gets cancelled. 2 root 3 minus 1 is right answer. So option 3 is right answer. Very, very important model. This is called parametric point. Parametric point. Parametric point on the straight line. R represents the distance between these 2 points. Okay. Next. The orthocenter of the triangle whose sides are given by x plus y plus 10 is equals to 0, x minus y minus 2 is equals to 0, 2x plus y minus 7 is equals to 0. Do observe that given lines x plus y plus 10 is equals to 0, x minus y minus 2 is equals to 0, both are perpendicular to each other. So third line is neither perpendicular nor parallel to these 2 lines. So very clear, triangle formed by those lines is right angled. For a right angled triangle, orthocenter is vertex at right angle. So vertex at right angle obtained by solving these 2 lines. Okay. X plus y plus 10 is equals to 0. X minus y minus 2 is equals to 0. In an objective examination, no need to solve these 2 lines also. Already answer is there in 4 options. Just it is enough to verify which option is satisfying these 2 lines. I am verifying with the first option. Minus 4 minus 3. Minus 4 minus 3 minus 7 plus 10 not 0. Minus 4 minus 6 minus 10 plus 10 0. Minus 4 plus 6 2 minus 2 0. Answer is second option. Okay. Even by solving also we get 2x plus 8 is equals to 0. X is equals to minus 4. By solving also we get x is equals to minus 4. On substituting x is equals to minus 4 in any one of these 2 equations, minus 4 plus y plus 10 is equals to 0. Y is equals to minus 6. Therefore, orthocenter is minus 4 comma minus 6. Okay, here we have used the orthocenter of a right angled triangle. A right angled triangle is the vertex at right angle. The vertex at right angle. The orthocenter of a right angled triangle is the vertex at right angle. Okay. Next problem. If the lines x plus y minus 1 is equals to 0, kx plus 2y plus 1 is equals to 0, and 4x plus 2ky plus 7 is equals to 0 are concurrent. Okay, 3 lines are concurrent condition is determinant of the coefficients is 0. Okay, determinant of the coefficients 1 1 minus 1, k 2 1, 4 2k 7 is equals to 0. While expanding the determinant, 1 into 14 minus 2k minus 1 into 7k minus 4 minus 1 into 2k square minus 8 is equals to 0. 14 minus 2k minus 7k plus 4 minus 2k square plus 8 is equals to 0, which is 2k square, bringing that side, minus 9k will be plus 9k, constant term 18 plus 8 26, minus 26 is equals to 0. Okay, so minus 52, 2k square plus 13k minus 4k minus 26 is equals to 0. K taken out common, 2k plus 13 minus 2 taken out common, 2k plus 13 is equals to 0. So 2k plus 13 into k minus 2 is equals to 0. K is equals to either 2 or minus 13 by 2. If k is equals to 2, this represents 2x plus 2y. X plus y minus 1 is equals to 0. 2x plus 2y plus 1 is equals to 0. Parallel lines if k is equals to 2. But concurrent lines means no two lines are parallel. That's why k is not equals to 2. Therefore, k is equals to minus 13 by 2 is required answer. So, do observe that even though after getting answer unable to decide the option, we are getting k is equals to 2 as well as k is equals to minus 13 by 2. That is the difficulty level involved in this question. If k is equals to 2, what will be happening? First line and second line both will be parallel. Coefficients are in proportional. 1 by 2, 1 by 2. They are parallel lines. But given that 3 lines are concurrent means no 2 of them are parallel. All the 3 lines are passing through the same point. Okay? Which is a contradiction to the hypothesis when k is equals to 2. That's why answer is third option. If theta is acute angle between the lines x by a plus y by b is equals to 1, x by b plus y by a is equals to 1, then sin theta is equals to. Do observe that first line can be written as bx plus ay minus ab is equals to 0. Second line can be written as ax plus by minus ab is equals to 0. Okay. Suppose lines are a1x plus b1y plus c1 is equals to 0. a2x plus b2y plus c2 is equals to 0. Sin theta will be modulus a1 b2 minus a2 b1 by under root of a1 square plus b1 square under root of a2 square plus b2 square. So this is sin theta. With the help of that, we can find sin theta is equals to modulus a1 b2 minus a2 b1 by under root of b square plus a square under root of a square plus b square. So this can be written as, inside of modulus we can also interchange the terms whenever minus sign is there. So that's why modulus a square minus b square by root of a square plus b square, root of a square plus b square will be a square plus b square. So that is there in option 4. Option 4 is right answer. Very simple question. Why do you know this formula? Okay. Next, problem number 8. if the incenter and circumcenter of the triangle formed by the lines x is equals to 2, y is equals to 3, 4x plus 3y plus 7 is equals to 0 are I and S respectively, then IS is equals to incenter and circumcenter. Okay, do observe that the given lines, one is horizontal, other one is vertical. So x is equals to 2 is a vertical line, y is equals to 3 is a horizontal line. These are perpendicular to each other, and this is the third line. This is the third line, 4x plus 3y plus 7 is equals to 0. Okay. Do observe that by solving x is equals to 2 line, y is equals to 3 line, we get 2 comma 3 is a point. This is orthocenter. Let it be capital A. This is capital B. Solving y is equals to 3 and 4x plus 3y plus 7 is equals to 0. Just substitute y is equals to 3. Already y coordinate 3 is fixed. Substitute y is equals to 3 in the given line. 4x plus 9 plus 7 is equals to 0. 4x is equals to minus 16. That is minus 4. Already solving these two lines, x is equals to 2 fixed. Substituting here 8 plus 7, 15 taken to right hand side, y is equals to minus 5. Okay. So this is the triangle with vertices. Orthocenter we know. Circumcenter is midpoint of hypotenuse. Somewhere here circumcenter. Okay. Do observe that circumcenter is midpoint of AB, that is 2 minus 4 by 2 minus 5 plus 3 by 2. 2 minus 4 minus 2 by 2, that is minus 1. 3 minus 5 minus 2 by 2, that is minus 1. This is circumcenter. We know already orthocenter. Okay. Orthocenter is 2 comma 3. Do observe that incenter, let it be x1 comma y1. This is x2 y2. This is x3 y3. Here to here distance 3 gets cancelled. 2 plus 4 6. This is 6. Here to here distance 2 gets cancelled. 3 plus 5 8. Here to here distance 2 plus 4 6 square 13 36. 3 plus 5 8 square 64. This is 10. Okay. Do observe that incenter formula is ax1 plus bx2 plus cx3 by a plus b plus c, ay1 plus by2 plus cy3 by a plus b plus c. So consider this is a small a, this is a small b, this is a small c. Okay. Now incenter is equals to ax1 10 into 2 20, bx2 8 into minus 4 minus 32, cx3 6 into 2 12 by a plus b plus c 10 plus 8 18 plus 6 24. Similarly ay1 10 into 3 30, plus by2 8 into 3 24 plus cy3 6 into minus 5 minus 30 by 24 is equals to 32 0 30 24 by 24 1. Now the distance between orthocenter and incenter, circumcenter and incenter, is will be under root minus 1 minus 0 whole square 1 minus 1 minus 1 whole square 2 square is 4, that is equals to root 5. Root 5 is right answer. So root 5 can be seen in option 1. Okay. Next, let's move on to question number 9. The orthocenter of the triangle formed by the points 1, 3, minus 3, 5, 5, minus 1. As we discussed shortcut about orthocenter in our earlier videos, if any two vertices x coordinates the same, any two vertices y coordinates the same, such a triangle is right angled. For a right angled triangle, orthocenter is the vertex at right angle. But here, such condition is not work out. This is not a right angled triangle. Suppose this is capital A 1, 3, capital B minus 3, 5, capital C 5, minus 1. Okay. This is orthocenter. Orthocenter is the point of concurrency of altitudes. Let the orthocenter be alpha, beta. Whenever orthocenter is alpha, beta, we know very well that from the diagram AD bar is perpendicular to BC bar. This implies slopes m1 into m2 is equals to minus 1. Slope of AD bar beta minus 3 by alpha minus 1 into BC slope 5 plus 1 6 by minus 3 minus 5 minus 8 is equals to minus 1. 2 3s are 2 4s, minus minus cancelled, which will be 3 beta minus 9 is equals to 4 alpha minus 4. This is 4 alpha minus 3 beta is equals to minus 5. Actually, orthocenter is there in options. Just it is enough to verify from options alpha beta. First option 4 into minus 8 minus 32. Beta is minus 10 plus 30. Minus 32 plus 30 is not equals to minus 5. First option rolled out case. 4 into minus 3 minus 12. Minus 12 minus 6 minus 18. We won't get this. 4 into minus 2 by 3 minus 8 by 3. Minus 8 by 3 minus 3 into 4 by 3 minus 12 by 3 minus 20 by 3. Minus 20 by 3 is not equals to minus 5. So this is 19. 4 into 19 76. Minus 3 into 27 51, which is also not equal. Here some option given wrong, I think. Okay, by verification we need to get if option is correct. By verification we get alpha, beta. So alpha, beta itself it is orthocenter. Why we have used AD bar perpendicular to BC bar? This is an altitude. So product of slopes is equals to minus 1. That is only we are using. But none of the option is satisfying. There may be mistake in options. If options given correct, we get in one of the option is our answer alpha, beta. Okay. Next 10. Question number 10. If the algebraic sum of the perpendicular distances from the points 2, 0, 0, 2, 1, 1 to a variable line is 0, then the variable line always passes through a fixed point. The coordinates of the point are. Here, algebraic sum. Let the variable line be. Here, variable line be ax plus by plus c is equals to 0. Here, perpendicular distance of this line from the point 2, 0 is p1 or d1. Perpendicular distance of this line from the point 0, 2 is d2. Perpendicular distance of this line from the point 1, 1 is d3 is equals to 0. Modulus perpendicular distance a into 2 plus b into 0 plus c by under root a square plus b square plus perpendicular distance of the line from the second point a into 0 plus b into 2 plus c by under root a square plus b square plus a into 1 plus b into 1 plus c by under root a square plus b square is equals to 0. So, however denominator is equals to 0, we are going to get 3a plus 3b plus 3c is equals to 0. A plus b plus c is equals to 0 can be written as a into 1 plus b into 1 plus c is equals to 0. It is looking like ax plus by plus c is equals to 0, where the point x comma y is equals to 1, 1. So, answer is fourth option. 2a plus a 3a, 2b plus b 3b, c plus c plus c is 3c. After the cancellation 3, we are getting a plus b plus c is equals to 0. If the sum of the coefficients is 0 in the equation of straight line, then it always passes through the point 1, 1. Okay. Question number 11. If capital A is equals to 1, minus 1, 2 related to 3D geometry, capital B is equals to 3, 4, minus 2, capital C is equals to 0, 3, 2, capital D is equals to 3, 5, 6, then the angle between the lines AB and CD, whenever AB and CD are given, drs of AB bar x2 minus x1, y2 minus y1, z2 minus z1 is the formula. That is 3 minus 1, 2, 4 plus 1, 5, minus 2 minus 2, minus 4. Let them A1, B1, C1. Similarly, drs of CD bar. drs of CD bar also using same formula. 3 minus 0, 3, 5 minus 3, 2, 6 minus 2, 4. Let them A2, B2, C2. Now, angle between these two, cos theta is equals to modulus A1, A2 plus B1, B2 plus C1, C2 by under root of A1 square plus B1 square plus C1 square into under root of A2 square plus B2 square plus C2 square, which is A1 A2 is 6 plus B1 B2 is 10 minus 16 by something which is 0. Therefore, theta is equals to 90 degrees. So, such two lines are perpendicular to each other. A1 A2 plus B1 B2 plus C1 C2 condition, we are getting 0. That's why angle between them is 90 degrees. Problem number 12. 1, minus 2, 1 is a point on the plane pi, and pi is parallel to the plane x minus y minus z is equals to 0. If the equation of plane pi is ax plus by plus cz minus 2 is equals to 0, then b minus 2c is equals to, this is a plane pi which is passing through the point 1 comma minus 2 comma 1. This is another plane whose equation x minus y minus z is equals to 0. This is the plane passing through this, this is the plane parallel to this plane passing through this point. Do observe that here we need to use one formula. The equation of plane parallel to ax plus by plus cz plus d is equals to 0 and passing through x1 comma y1 comma z1 is a into x minus x1 plus b into y minus y1 plus c into z minus z1 is equals to 0. That is 1 into x minus 1 minus 1 into y plus 2 minus 1 into z minus 1 is equals to 0. Therefore, equation is x minus y minus z minus 1 minus 2 minus 3 plus 1 minus 2 is equals to 0. On comparing this with ax plus by plus cz minus 2 is equals to 0. Minus 2 same. That's why a is equals to 1, b is equals to minus 1, c is equals to minus 1. Question is to find b minus 2c. b is minus 1, minus 2 into c is minus 1, plus 2 minus 1 is 1. 1 is nothing but a. So right answer is a. 1 is a here. That's why answer is fourth option. Okay. Simple question. Just we have used here this formula. So this is the formula we have used. Okay. Next. Problem number 13. If capital A 1 comma 2 comma 3, capital B 3 comma 7 comma minus 2, capital C 6 comma 7 comma 7, capital D minus 1 0 minus 1 are points in a plane, then the vector equation of the line passing through the centroid of triangle ABD and triangle ACD. First, centroid of triangle ABD. Let us calculate. ABD, x1 plus x2 plus x3 by 3, 1 cancelled, 3 by 3 is 1. 2 plus 7, 9 plus 0 by 3, 3. 3 minus 2, 1 minus 1, 0 by 3, 1. Which can also be written as I bar plus 3j bar. Okay. Let it be small a bar. Next, G2 is centroid of triangle ACD. Centroid of triangle ACD, 1 plus 6, 7 minus 1, 6 by 3, again 2. 2 plus 7, 9 by 3, 3. 3 plus 7, 10 minus 1, 9 by 3, 3, which is 2I bar plus 3J bar plus 3K bar, which is B bar. R bar is equals to A bar plus T times B bar minus A bar, which is R B bar plus T into A bar minus B bar, whichever you like. So R bar is equals to A bar plus something is not there anywhere. That's why B bar plus we are using this 2i bar plus 3j bar plus 3k bar plus t times a bar minus b bar or b bar minus a bar. Okay, 2i bar minus i bar, 3j gets cancelled, plus 3k bar. Okay, so this is answer. R bar is equals to 2i bar plus 3j bar plus 3k bar plus t times I bar plus 3k bar. I think this is k bar, I think. Okay, so this is answer. Whichever the formula, according to options we need to change. According to options we need to change. Okay, so that's why I think third option is right answer. Next, problem number 14. If 2 comma minus 1 comma 3 is the foot of the perpendicular drawn from the point origin to a plane, then the equation of the plane is simple. This is a plane, somewhere here origin, this is a perpendicular drawn from origin to the plane. Foot of the perpendicular already 2 comma minus 1 comma 3 given. Okay, do observe that point should lie on the plane. Just by verification this point lying on the plane we get answer. No need to do anything. First point, first option, 2 into 2 4, minus 1 3, minus 9, minus 6 plus 6 0. Second option, 4 plus 1 5, 5 plus 9 14. Yes, this is also getting. So more than one option is getting. That's why consider px comma y comma z, or else OF bar drs we need to calculate. Drs of OF bar, O is 0 0 0, 2 minus 0, minus 1 minus 0, 3 minus 0. Point F is x1 comma y1 comma z1, that is 2 comma minus 1 comma 3. The equation of plane, a into x minus x1 plus b into y minus y1 plus c into z minus z1 is equals to 0. This is 2 into x minus 2 minus 1 into y plus 1 plus 3 into z minus 3 is equals to 0. 2x minus y plus 3z minus 4 minus 1 minus 5 minus 9 minus 14 is equals to 0. So that is there in second option. Second option is right answer. Okay. Next, question number 15. If the foot of the perpendicular drawn from the point 1 0 minus 2 to the plane pi is 2 0 minus 1, equation of plane is this, then a square plus b square plus c square. Same model, but instead of origin some other point given. From the point capital A 1 0 minus 2, somewhere here foot 2 0 minus 1. Okay, let us calculate drs of AF bar. Drs of AF bar, 2 minus 1 1, 0 minus 0 0, minus 1 plus 2 1. Let them a comma b comma c. Point F is equals to 2 0 minus 1. Let it be x1 y1 z1. Simple. Okay, equation is a into x minus x1 plus b into y minus y1 plus c into z minus z1 is equals to 0. 1 into x minus 2 plus 0 into y minus 0 plus 1 into z plus 1 is equals to 0. x plus 0y plus z minus 2 plus 1 minus 1 is equals to 0. So x plus, there may be any number of constant. Adjustment of constant does not depending upon ABC values. Okay, no problem. Here a value 1, b value 0, c value 1. A is equals to 1, b is equals to 0, c is equals to 1. A square plus b square plus c square will be 1 square plus 1 square 2. First option is right answer. Okay. There may be some mistake. Of course, if it is not adjust also, no issue. Why? Because adjustment of constant does not affect ABC values. That's why. Problem number 16. Let the foot of the perpendicular drawn from the point 1, 2, 3 to the plane be minus 1, 3, minus 2. Then the perpendicular distance from the origin to the plane. Okay. This is capital A. This is capital F. Same as previous models. DRs of AF bar 1 plus 1, 2. 2 minus 3. Minus 1, 3 plus 2, 5, A comma B comma C, point x1 y1 z1, point x1 y1 z1 is 1, 2, 3. Now the equation of plane is 2 into x minus 1 minus 1 into y minus 2 plus 5 into z minus 3 is equals to 0. 2x minus y plus 5z minus 2 plus 2 gets cancelled, minus 15 is equals to 0. So perpendicular distance from origin is modulus of constant by under root a square plus b square plus c square, that is 15 by root 30. 15 by root 30. 15 by root 30 can be written as root 10 into root 3. This is 3 into 5. This is root 3 into root 10. 3 gets cancelled, root 3. Root 5 times gets cancelled, here root 2 left. So root of 15 by 2. Root of 15 by 2 can be seen in option 2. Okay. Next problem. Capital A 1, 1, 1. Capital B 1 minus 4, 3. Capital C 2 minus 2, 0. Capital D 8, 1, 4 are the vertices of tetrahedron. G1, G2, G3, G4 are centroids of the faces ABC, BCD, CDA and DAB respectively. Then the centroid of tetrahedron having G1, G2, G3, G4 as its vertices. Very simple. G1 is the centroid of the face ABC. ABC centroid 1 plus 1, 2 plus 2, 4 by 3. 1 minus 4, minus 3 minus 2, minus 5 by 3. 1 plus 3, 4 by 3. This is G1. G2 is equals to centroid of BCD 1 plus 2, 3 plus 8, 11 by 3. Minus 4 minus 2, minus 6 plus 1, minus 5 by 3. 3 plus 0 plus 4, 7 by 3. Next, G3 is centroid of triangle CDA 1 plus 2, 3 plus 8, 11 by 3. 1 minus 2, minus 1 plus 1, 0 by 3. 1 plus 0 plus 4, 5 by 3. 5 by 3. Next, G4. G4 is the centroid of DAB. Last, first, second. 8 plus 1, 9 plus 1, 10 by 3. 1 plus 1, 2 minus 4, minus 2 by 3. 4 plus 1, 5 plus 3, 8 by 3. So these are the vertices of tetrahedron. Now centroid of tetrahedron is x1 plus x2 plus x3 plus x4 by 4. Okay, x1 plus 4 by 3 plus 11 by 3, 15 by 3, 11 by 3, 26 by 3, 36 by 3, 36 by 3 by 4. Next, minus 5 by 3, minus 5 by 3, minus 10 by 3, minus 2 by 3, minus 12 by 3 by 4, 4 by 3 plus 7 by 3, 11 by 3 plus 5 by 3, 16 by 3, 24 by 3 by 4, which is 12 by 4, 3, minus 4 by 4, minus 1, 8 by 4, 2, 3, minus 1, 2. Okay. Here we have used centroid of triangle formula x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3, z1 plus z2 plus z3 by 3. Each face of a tetrahedron is triangle. Centroid of tetrahedron formula x1 plus x2 plus x3 plus x4 by 4, y1 plus y2 plus y3 plus y4 by 4, z1 plus z2 plus z3 plus z4 by 4. So that is the concept we have used. 18. The DCs of the lines making angles pi by 4, pi by 3 and theta respectively with x comma y comma z axis are given here. Alpha is equals to pi by 4, beta is equals to pi by 3, gamma is equals to theta. We know very well that cos square alpha plus cos square beta plus cos square gamma is equals to 1, cos square pi by 4 plus cos square pi by 3 plus cos square theta is equals to 1. This is 1 by 2, this is 1 by 4, this is cos square theta is equals to 1. So cos square theta is equals to 1 minus here 3 by 4, 1 by 4. Cos theta is equals to plus or minus 1 by 2, but theta lies in the first quadrant, that's why cos theta positive. Now cos theta positive, that is 1 by 2. So that's why DCs are cos pi by 4, cos pi by 3, cos theta, cos pi by 4 1 by root 2, cos pi by 3 1 by 2, cos theta also we got 1 by 2. These are DCs, can be seen in first option. Okay. Next, question number 19. The Cartesian equation of plane parallel to the plane and at a distance of 2 units from it. Okay. Do observe that in order to convert into Cartesian equation, we have to consider r bar is equals to xi bar plus yj bar plus zk bar. Now r bar dot 2y bar plus 3j bar minus 4k bar is equals to 1 implies 2x plus 3y minus 4z is equals to 1. Now it's a parallel plane equation. Parallel plane equation should be of the form 2x plus 3y plus 4z plus k is equals to 0. Okay, distance between these two planes already given, that is modulus d1 minus d2 by under root a square plus b square plus c square, which is nothing but here by bringing this side constant term will be minus 1 modulus k plus 1 by under root 4 plus 9 plus 16, okay, 29. So modulus k plus 1 is equals to plus or minus 2 root 29. Therefore k is equals to minus 1 plus or minus 2 root 29. K is equals to minus 1 plus or minus 2 root 29 can be seen in So this, while substituting here, we get 2x plus 3y plus 4z is equals to minus k. Minus k will be 1 plus or minus 2 root 29. Okay. Options in the form of 2x plus 3y plus 4z is equals to minus k form. No. That's why. So second option is our answer. Okay. Question number 20. If 2 comma minus 1 comma 2 and k comma minus 3 comma 5 are triads of direction ratios of two lines and the angle between the lines is 60 degrees, then a relation in terms of k. Whenever we know direction ratios of two lines, angle between them, cos theta is equals to modulus a1 a2 plus b1 b2 plus c1 c2 by under root of a1 square plus b1 square plus c1 square under root of a2 square plus b2 square plus c2 square. Okay. So that's why here angle is 60 degrees, modulus a1 a2 2k plus 3 plus 10 by under root of 4 plus 1 9 under root of k square plus 9 plus 25 34. So cos 60 is 1 by 2. However, this is 3. By cross multiplication, we are going to get modulus 4k plus 26 is equals to under root of 9 times k square plus 34. Okay. This is squaring on both sides. 16k square plus 26 square 676. 2ab 2 into 4 8 into 26 8 6s 48 208 is equals to 9k square plus 9 into 34 9 4s 36 27 306. So by bringing this side, we get 7k square something. No, 7k square something, there is only one option. 7k square minus 112k minus 110 is equals to 0. Okay. So these are the models from 3D geometry, 2D straight lines, pair of straight lines, vectors. So thank you one and all. Please follow my YouTube channel Srinivasa Academy for more and more updates. Thank you.